Alright, so hopefully you've watched part 1 and part 2, and I've gone through the first one and I've done B. Now I'm going to do E, 2E, so you can see how I'm using the quarter period to find out that x minus pi 3. That x minus pi 3 is going to be a pain to do, because you notice that all the other questions, the endpoints, we didn't really spend time finding the endpoints. That was pretty easy to do. Same thing with the first one. You see the endpoints are already given as we were looking for the like quarter cycles. But this one, on the other hand, you actually have to solve the endpoints. Okay, so I'm going to show you. Here we go. We're going to do this problem. Y equals to 2 times cos of 2 bracket x minus pi on 3 minus 1. So same things again. We're going to go through amplitude, which is 2. That tells you the amplitude. Okay. Be careful with the period. The period is actually this 2 here, even though it doesn't look like it's next to the x. If you expand the bracket, it's 2 times x and 2 times that. 2 times x gives you the coefficient, so therefore 2's n. So 2 pi on n, which is 2 pi on 2, the period is pi. So that means the quarter period is equal to pi on 4. Okay. Next part, we now need to know if I'm moving left or right. So this is responsible. So because of whatever that thing is that you have, that will be responsible for your left and right. So if I want to answer the question here, I would say now 2 times x minus pi on 3. I said let it equal to 0. That's been always my technique. Divide both sides by 2 and you get x minus 3, and that's still 0. And then solve for x, that's now pi on 3. So what does that mean? That just means you're moving to the right by pi on 3. Okay, you got it right by pi on 3. And then finally reading this one, this tells me down 1. Okay, keep in mind there's that 2, so that changes the period and it also changes the domain. So the current domain right now is between negative pi and pi. So if I write 2x, then you're actually going to go between negative 2 pi to 2 pi, because you're doubling it. You times it by 2, times it by 2. This is going to be useful when you start solving for x-intercepts, okay? But for the time being, we're just going to use the quarter cycle and the amplitude to give us an outline of our problem, okay? So let's draw it. Here we go. Actually, I should do the center bit more centered because it's from negative pi to pi. Yeah, so I'm going to do this and just start drawing again. So let's do it centered. Okay, and here we go. We got our amplitude, which is at 2, right? So it used to be at 2 and it used to be negative 2. What have we done? And the center was at 0. Okay, those are our 3 lines. Now we know that it's going down 1. So if I'm going down 1, then 2 minus 1 now brings me to 1. So the top now comes down to 1. From the middle, so center, which is at 0, goes down 1. So now it's at negative 1. And then from negative 2 going down 1 gives me negative 3 now. Okay? So as you can see, I'm just going to rub this out so I don't confuse you. I'm just rubbing these points off. Okay, so these are my new maximum, minimum. So I'm going to do the dotted lines again. Okay, I'm going to do the dotted lines. That was top, center, and the bottom end. Okay, now the reason why this is tricky as well is because you also have the go to the right by pi on 3. Now, keep in mind this is a cos graph, not a sine graph. Now, cos graphs, if you remember, cos graphs start at the maximum, and then it goes to center, minimum, center, maximum again. Okay, so that means my first point, which used to be at 1, it should have been here, it's actually now moved to the right by pi on 3. Okay, so it's moved to the right, and I'm just going to make it up, and I'm going to say pi on 3 is here. Okay, I'm going to just rub that cornered off. Yeah, there we go. And I now know that it's moved to the right by pi on 3. So that's my first point. Okay, now here's the tricky part. So now I know that's the starting point, right? That's the starting point. What you need to understand is, if that's my starting point, which is pi on 3, how far is it from the start to the center? So the top end to the middle, and then middle down to the bottom, bottom to the middle, and then middle back to the top. So maximum, center, center to minimum, minimum to center, right? We said that the quarter period is pi on 4. That's how far it is to make that quarter cycle. So pi on 3 plus pi on 4, that gives me now, if we rewrite it with the same denominators, this would be, what is that, times 4? So 4 pi on 12 plus 3 pi on 12. Okay, so that means instead of writing pi on 3 here, I'm just going to fix this point because it makes it easy if you keep it all in 12s now. So if I just fix this, the quarter cycle now is at 4 pi on 12, which is technically pi on 3 to the right, so 4 pi on 12. To get to the next one, I need to add 3 pi on 12. So if I add to the next one, add another 3, makes it now 7 pi on 12. True? To get to the next quarter cycle, it would have to be now 10 pi on 12. To get to the next quarter cycle, it will now have to be 13 pi on 12. Now, what I hope that you picked up is 13 pi on 12 is actually above the current domain. The domain is pi. So 13 out of 12 is obviously too much. Okay, so now let's draw the main points. Now remember, a cost graph had, this is your first, starting from the top, maximum, goes down to the center, then down to the minimum, right? So I'm going to do the same. The quarter cycle, this is at 7 pi on 12, it should be at the center. At 10 pi on 12, it should be at the minimum. And then at 13 pi on 12, it should have reached the center again. But what we know, okay, what we know is that that's not going to happen. That's not going to happen because 12 pi on 12 would have finished earlier. So that means it has to finish somewhere here, hypothetically. So I know the graph went from the top down and it comes back up, but before even reaching it back to the center, it stopped. Okay? So this is what I mean. You don't know what the endpoint is. You don't know what that endpoint is, but you do know that this is at 12 pi on 12, which is technically at pi. Okay? So if I were to really, now I just need to know, well, when it's pi, which is 12 pi on 12, what is my y value? See, I need to find an endpoint now. See, previously I didn't have to do that. Now I do. Okay? Now, just before we find the endpoints, I'm just going to leave it there. And I'm going to continue this quarter cycle journey until I finish up until negative pi. Okay, so let's follow this quarter cycle journey. So if I had to move from 4 to 7 was add another 3, then going backwards, the next quarter cycle has to be at pi on 12. True? Because 4 take away 3 give me 1. So pi on 12, I should reach the center. Pi on 12 minus another 3, so that gives me now, what's that? 1 minus 3 is negative 2 pi on 12, and then negative 2 take away 3 gives me now negative 5 pi on 12. Take away another 3, that gives me now negative 8 pi on 12, and then take another 3, that gives me now negative 11 pi on 12, and I'm really close to that pi. Now, take another 3 gives me now negative 14 pi on 12, which is clearly too far. Okay, I've only got from negative pi to pi. So now let's put our points in. So it went from maximum backwards, now back to the center. Now at negative 2 pi on 12, it should be at the minimum, which is here. So that's my minimum. And then it goes back to the center at negative 5 pi on 12. And then at negative 8 pi on 12, it should reach its maximum. And then when it reaches negative 11 pi on 12, it should reach the middle. Okay, but remember, negative 12 on 12, which has to be somewhere here, that's when you get negative pi. And then obviously you would have to finish maybe somewhere here before you even reach the minimum, because when from center it has to go to minimum, right? So right now, this endpoint, I just know that this is negative pi. What I don't know is what the y value is. See, it's very different from before. Before you did know what the endpoint is, now you don't, because you're moving the graph left and right. So if I were to join the dots right now, this is what the graph should look like so far. Okay, that's, at least you've got a picture of what it looks like. See what I'm doing? And now I'm just going to delete all those little dots so you don't get confused. I'm just gonna remove of that so you can see it's a very clear graph, and it looks nicer too, doesn't it? Because you got the maximum, you got the minimum, then you got everything sort of written nicely there. Now, there you go. I'm just trying to clean up that mess there. You don't need the 14 pi. Oh no, how do I? Maybe I'll just zoom in a bit, and I'm gonna delete that 14. There you go. Okay. So what do I need so far? I've got the shape of the graph. I need the endpoint. So I've got pi on the left. On the left here, I've got negative pi and I've got pi. Logically, they should have the same y value because it's you've kept it even from negative pi to pi, so it's symmetrical. So obviously, it has to end up at the same y value. But let's now find the endpoint. So how do you find the endpoints? When x equals negative pi, you want to find y value. So y was equal to, what was the function again? It was 2 times cos of 2 times x minus pi on 3. Okay, so I'm going to sub in pi, so it makes it 2 times pi minus pi on 3. Actually, there was a minus 1. And let's work this out. So 2 times cos of, what's that? Pi minus pi on 3 is 2 pi on 3. So that makes it 4 pi on 3 minus 1. At this point, if you want to use a cas, you can use a cas as well. I personally know where 4 pi on 3 is. It's in a unit circle. That's technically pi with an extra pi on 3. So cos is negative, and cos of pi on 3 is half. So this is times negative half. Yeah, times negative half. 2 minus 1. Cancel out the 2, so minus 1, minus 1. So negative 2. So that tells me this is negative 2. Now I also know that the other endpoint has to be negative 2 as well, but let's say I didn't know. Oh, I just realized I subbed in pi, so let's do, whoops, this was negative 2 here, and let's sub in pi. I made a mistake. So let's see what happens when it is negative pi. So at x equals to negative pi, same drill. Y equals 2 times cos of 2 times negative pi minus pi on 3 minus 1. So same drill, 2 times cos of, and now this is negative pi, so that's minus 4 pi on 3 minus 8 pi on 3. Okay, so I'm just doing 3 times negative pi is negative 3. Negative 3 minus 1 is negative 4, but negative 4 times the 2 gives me negative 8 pi on 3 minus 1. Now 2 times cos of negative 8 pi on 3, so again using the unit circle, negatives, that's negative 8 pi on 3 is the same thing as writing negative 9 pi plus pi on 3. True? Because negative, what am I doing? It is the same thing as writing negative 9 pi on 3 plus pi on 3. And that's the same thing as negative 3 pi plus pi on 3. True? Okay. So starting at 0, this would give you negative pi. All the way here is negative 2 pi, and then negative 2 pi down here. So negative 3 pi is at this point. And I'm now adding pi on 3. So remember, when you're adding, you're going anti-clockwise. Okay. So that means I have to be in this quadrant. There you go. And cos again is negative, so that's why I know cos of pi on 3 would be then negative half. So it ends up being the same answer as before, which I was correct. Okay. So I got my endpoints. I got my shape. What am I missing? X-axis intercepts. Okay. So here we go. Now remember, I said this is the key part when you're solving x-axis intercepts. I said that if you have that 2 that we're focused on, that 2 there, that's got to matter. Okay. And the tricky part is there's that x minus pi on 3. Now I told you that I'm not going to teach you the way I teach my year 12s. I'm going to get you to trial and error. Okay. So here we go. We know that we should have 1, 2, 3, 4 solutions. Okay. So let's solve for the x-intercept now. Let's try this. We've got y equals to 2 cos of 2 times x minus pi on 3 minus 1. Let y equal to 0 to find x-intercepts. Okay, so you got 2 cos of 2 bracket x minus pi on 3 minus 1. Bring the 1 across, so 1 equals 2 cos of 2 times x minus pi on 3. And then divide both sides by 2, so you got half cos of 2 times x minus pi on 3. Okay, and then cos inverse of half. So remember, the question is, what does cos represent? Cos represents your x values, and when is x values positive half? Okay, so if I draw out my unit circle, okay, my unit circle, then when is cos positive half? Well, this is the x-axis. That's when it's half, so that means the 2 points that correspond to an x-coordinate of half have to be those 2 points. So what's my problem? Again, my problem is I don't know the angles. I don't know what angle this is. I don't know the length, and I don't know the length on the outside, so the radians. I don't know the angles. But what I do know is from my exact values, I can work out what the length should be to, cos of what to give you half, okay? Now we know that cos of pi on 3, which is 60 degrees, this is pi on 3, this is also pi on 3. I know that's what will give me an x length of half, okay? Now, to answer the question, I'm just going to fill out this side here. This was 2 bracket x minus pi on 3. Now remember, I told you you're going to have to work with this new domain because there's that number 2. That number 2 to the x will make a difference, okay? So here we go. We're going to solve the problem where its domain is from negative 2 pi to 2 pi. So I'm going to start at negative 2 pi, which is again over here, negative 2 pi, and I work all the way around and I hit my first solution. Okay, so let's write down my possible solutions so far. My possible solutions were from negative 2 pi. I'm starting at negative 2 pi, so I'm starting at negative 2 pi, and I know that I have to, when I'm going anti-clockwise, it's adding. So add by pi on 3. Okay, because that's how much I needed to add to get there. Okay, then after I've done that, now I'm going to go all the way around and I reach here, that's negative pi. No solutions. Until I reach all the way, I'm going all the way back to make it back to 0. So from negative 2 pi, negative pi, this is now 0. True, when I get back, that's 1 full revolution, it's 0. But remember, I hit another solution. And so I know it has to be 0 minus pi on 3. Because from 0, I'd have to subtract to go back. Okay? So those are my first 2 solutions, right? But remember, I need to continue until I get to 2 pi. Okay, so I'm just going to rub all this out so you don't get confused. I've just done my 1 cycle, true? I've just done my 1 cycle, and this is what I need now. So I've done my 1 cycle, and I've landed back at 0. This is where I was at. I was at 0, and then I continue the cycle until I get to 2 pi. So I'm going to continue, and I hit my next solution. So it's 0 plus pi on 3. Okay, and I continue around the circle. I reach now, this is pi, because from 0, half circle is pi, and they go all the way. Now here, that's 2 revolutions. I get 2 pi, but remember, I'm hitting a 4th solution, which is 2 pi minus pi on 3, because I'm going back to that point from 2 pi. Okay, so this now leaves me with the 4 possible answers is negative 5 pi on 3, negative pi on 3, pi on 3, and 3 times 2 is 6, that's 5 pi on 3 here. Okay, those are my answers there, but remember this answer was for a dilated domain. Okay, so remember I doubled everything. I have the answer, remember it was on the right hand side, I had 2 times x minus pi on 3. Yeah? So now, because I've stretched everything by a factor 2, I have to now shrink everything by a factor of 2. So I'm going to divide this by 2, divide by 2, divide by 2, divide by 2, divide by 2. What that gives me, okay, so this cancels out, and this will give me the new line where it shows x minus pi on 3 is equal to negative 5 pi on 6, negative pi on 6, pi on 6, 5 pi on 6. Which makes sense now. See, that all fit into the domain of pi. What you have to be careful though okay? Because now, remember, we also moved the graph to the right. Remember, where did we read it? We said down here it was right by pi and 3. So these are the solutions if I didn't move the graph left or right, but I did. So because I'm moving to the right by pi and 3, I'm going to now say add by pi and 3. So plus pi and 3 will add to the right, to the right, to the right, to the right. Okay, so I've got to add by pi and 3, which this cancels out. So x is now equal to negative 5 pi on 6 plus pi and 3 is the same thing as saying negative 7 pi on 6. Okay, because I'm doubling the denominator. So double 3 gives you 6 and double the numerator, so it's 2 pi. Whoops, it's not 7, it's plus. Whoops, my bad. It should be negative 3. So here we go, it should be negative 3. So I'm going to write down my answers here. Negative 3 pi on 6. And then negative pi plus 2. That's pi on 6. And then I've got, pi on 6 plus 2. So 3 pi on 6. And then 7 pi on 6. Which this actually brings us out of the domain. 7 pi and 6 is bigger than what we need. Then we got to check, well then, do we have any other ones before negative 3 pi and 6? And how you check that, remember I said you can do trial and error, where you minus this by 2 pi and you minus this one by 2 pi, because it's one revolution. Yeah, so think about it, negative 3 pi and 6 starts off here. That's negative 3 pi and 6. Then if you want to know if I have another solution that fits in, then you got to minus one revolution, right? Just to see where I land. So that's what I'm going to do. I'm going to minus 2 pi. So let's check. Negative 3 pi and 6 minus 2 pi. So I'm going to write here negative 3 pi and 6 minus 2 pi. What's that? 6 times 2 is negative 12. Negative 12, so negative 15 pi and 6. That's out of the domain. That's more than pi. Then you do pi now. Pi minus 2 pi. So pi and 6 minus 2 pi, and that gives me 6 times negative 2 is negative 12. Negative 12 plus 1 is negative 11 pi on 6. And again, that's too big. So I'm going to test the other ones as well. So let's test the 3 pi and 6, so minus 2 pi. Let's try that. What about 3 pi on 6 minus 2 pi? And that gives me what? Negative 12 plus 3. Negative 9 pi on 6. And that's still too big. And then finally 5 pi and 6 minus 2 pi. So I'm minusing this by 2 pi. Just double checking. So this is all checking my possible answers. Okay, all my possible answers here. So minusing them all by 2 pi, and that gives you negative 12 plus 5 is negative 7 pi on 6. Okay, so it looks like each revolution should be fine. So that means there must be one more in between. Oh, because remember, we're meant to have 4 solutions here. There's meant to be 2 in the negative region. We've got the pi and 6 here. That was our answer. We've got the next one, which was 3 pi and 6. Okay. We've got the negative 3 pi and 6, but we're missing one of the solutions. So, if this is negative 3 pi on 6, then that means we need to get the next one. Now, in that case there, what you can see, I'm just wondering why I don't have, technically it's pi and 6 minus. Pi and 6 minus 2 pi. Did I do pi and 6 minus 2 pi, negative 12, negative 11 pi and 6? What was the domain, wasn't it? Yeah. Oh, you know why? I just realized because if I were meant to add and subtract, it was meant to be to these ones. and then you convert it, because the period is not 2 pi anymore. 1 revolution is actually pi. Whoops, my bad. Okay, so I got to go back and rewrite all this again. So it wasn't 2 pi. I had to subtract it by pi. My bad. Okay. This is what I mean. Like, this is why I don't like doing the trial and error, and I teach my year 12s to change the domain. But here we go. Just for argument's sakes, we now know that. Remember the period over here, we had pi before. So when you actually get your final answers here, what you were meant to do is test by adding and subtracting to see if you get an answer or not. And we can tell that this doesn't fit the domain. So we know that we're going to have to subtract pi, subtract pi, subtract pi. So here we go. We've got negative 3 pi on 6 minus pi. And that gives me, what, that's negative 6 minus 9 pi on 6. That's more than pi, so that doesn't work. Pi on 6 minus pi. And you get, what's that, negative 6 minus 7, no, minus 6, minus 5 pi on 6. Does that work? Negative 6 plus pi. Yes, there you go. See, that one fits. That's in the domain. So you should have another one which is negative 5 pi on 6. Whereas if you actually did the next one, 3 pi on 6 minus pi, this is negative 6 plus 3. Negative 6 plus 3 is negative 3 pi on 6, which we already got the solution. Okay, we already got this over here. Okay, so the one that we're missing is negative 5 pi on 6. So now I know this is negative 5 pi on 6. There you go. Okay, alternatively, what I was going to say as well was you can tell that from when you got the first two solutions over here, you had pi on 6 and you got 3 pi on 6. Well, then the distance is 2. So if you want to find the next one, the distance has to be 2 as well. So negative 3 minus 2, negative 5 pi on 6, that was one of it. But what I wanted to teach you was how you can use the period to find out if you're in the domain or not. Because if you don't do that, you're always going to miss the solution. Okay? But there you go. So you can see how tricky this exercise really becomes, especially when you move it left and right. So there you go. You got your endpoints, you got your cycles, and then you got the x-axis intercepts. That's what makes this whole thing really difficult. Okay? So please really have a go. I've done 3 different examples where you move up, down, left, right. And I've done one in class as well. I think I did... Which one did I do in class? I forgot which one I did. I think I did 1E. That's what I did. I did 1E. So hopefully you're getting a better vibe of what you need to do. But you can see how many of those exercises are so important for you to do. So make sure to practice 14H. And you got to know 14E, 14F by now. Okay? Otherwise you're really falling behind. But there you go. If there's any other questions specifically with this sketching that you need, do let me know which parts. I think what's normally most confusing is this, the solving part for the x-intercepts. Okay, that's 14H primarily. So if you're really having troubles with this section that I was just talking about, that's 14H. Okay, practice 14H if you're having difficulties solving. Okay, but I'm pretty sure finding the maximum, center, minimums, center, maximum, center, and then the endpoints, I'm pretty sure you don't have much issues there. Okay, it's the finding x-intercepts that you got to focus on. That's generally the difficult part. Okay. All right, I'm going to stop the video here. So that's 3 parts there. 3 parts to pick up on.